Hello. In this video, I'm going to show you how we can write some settings in ANSYS Fluent into a file and then use it into another new file. So as you know, after creating every necessary setting in Fluent, such as material properties, boundary conditions, solver settings, and other settings, sometimes we would like to export these settings into a file, such as a text file, and then import it into another Fluent case in order to avoid spending time on it. So here we have three modules of Fluent. In the first one, we want to use this setup and write it into a file, and then use it into another Fluent case. So this is double precision, and we open the file, the Fluent file. This is a simple geometry, a 2D geometry of a square, and it's a solid geometry. So we have some settings on this file. So then first we check our settings here, and then we write the settings into a file from the TUI here in the text user interface. So this is our geometry, a solid geometry. The boundary conditions are the bottom, left, top, and right, and the solid is has a copper material. So as you can see here, this is our energy equation, which is on, and we add copper as solid material and then assign it to our solid geometry. In the boundary conditions, we set a constant temperature to the bottom. As you can see here, 373 Kelvin, and the top one is I think 300 Kelvin. Yes, as you can see here, it's a constant temperature, and the left and right boundary conditions are the default and the zero heat flux. Also, we add a report definition as the average temperature of our zone, solid zone. So we have some settings here. So now we want to write these settings into a text file. So as you can see here, we can use some options here in the TUI window. So first we can use enter. As you can see here, we have some different options, and each of them has some subcategories. So we want to use file, so we can just write file and then use enter, and when we use another enter, we reach to the subcategory of file. So as you can see here, the right setting is the option that we want to use. So we can write or comment, write setting, or we can select or desirable or comment, and then use the middle bottom of the mouse. So you can see that this setting will be copy and paste on here, and so we can use enter again to run this command. And as you can see here, we need an output name for our file name. So I assign BC1 as a boundary condition, for example, name, and then enter. So these settings are right to a file with the BC1 name, and you can find it into the ANSYS workbench folder This is our file, right setting file, so open it, dp0, and this is our first module of Fluent. And in the Fluent folder you can see this file. You can open and even edit this file with a user with a text editor like Notepad, Notepad++. So all of your settings are in this file, and for example we can search for 373, and in the boundary condition here you can see this is our bottom wall, for example, boundary condition, and the boundary condition is set to constant temperature, and the temperature is 373 Kelvin. So now we have this setting into a file, text file, so we can close the for ANSYS Fluent. First we can maybe reset this file, so we have no setting on this Fluent file, and we open double precision because the previous one was the double precision. It's not important, but if you don't use this tick, you have a warning in the Fluent after using or BC1 file. So here the geometry is different from the previous one, but the boundary condition names and or your zones must be the same as the previous one, because your exported file needs to find your exact boundary conditions name and set the setting. So as you can see here, the geometry is different from the previous one. The previous one was a square, but here we have a rectangular with a different dimension. So as you can see here, the energy model is off, the material is just the aluminum, cell zones, boundary conditions, for example the bottom has a zero heat flux, and because the energy is off, so we have no settings here, and the report definition is empty, so we want to use our exported file in the previous Fluent. So first we can copy and go to new one, paste here, so we can use again the TUI interface. So enter and then use file enter, so we access to the subcategory of files, but here we want to read or settings, so we have to use another option. When you search here, you reach to read settings in this part. You can type or select this read setting and use middle bottom of the mouse, so you have this setting here, and use enter. So here we have to give the name of our file as the input file. So BC1 is the file that we put into the Fluent folder, so it has access to it, and as you can see here, after a while the options will be set. For example, here energy is off, now it will be changed, energy is on, the copper is added to or solid material, or solid zone is assigned to the copper, the boundary condition, for example the bottom set to constant temperature and 373, and the other option or report definition is set here as the average temperature of the solid. So as you can see here, we simply set our previous boundary conditions to this new file with a different geometry but the same name. So just for saying that if the name of our zone or boundary condition changed, how affect on this method. So we use the first geometry but with a different name for our top boundary condition. I changed the top boundary condition name to top 2. This is the same geometry as the first one, but the boundary condition here is changed to top 2, as you can see here. The energy is off, so this is the default setting of the ANSYS Fluent. In the solid material we have just aluminum, and for example the bottom boundary condition is set to default, and we have no report definition. So again we can copy to the third one, paste here. So again use enter, file enter, and read setting, middle bottom of the mouse, enter, PC1 as our file name. So some settings are changed, but you will see that we have some errors or warning. As you can see here, the energy equation is on, the copper is added, the bottom wall changed to constant temperature as 373, but the top 2 has the default setting as heat flux 0, because the name of this boundary condition changed, and the Fluent couldn't find the boundary condition with top 2. But here we have our report definition as our average temperature. You have to notice that if we changed our zone name from solid to, for example, solid 2, so we have an error here. Here we have also an error here because of changing the name of cell zone. So this is a simple way to export your settings of Fluent into a file and using for different geometry and different run in the Fluent. But as you could see here, the name of the boundary condition zones have to be the same. So thank you for watching.